In this section, we are going to talk about 3.5 graphing techniques. In the previous section, we looked at some basic graphs that we could use. And in this section, we talk about techniques that we can use with any graph. And we'll be using those previous graphs as examples. So first, let's start with y is equal to x squared. This is one of the graphs that we looked at last time. In order to look at that, we plotted some points. I've given them to you here. So this is from the last video. And then if we wanted to graph these, we could come over here to the graph and we could graph them. And I'm going to do this in red so we can tell it apart from our other graphs. So we would have 0, 0, 1, 1, 2, 4. We'd have negative 1, 1, and negative 2, 4. And remember that x squared is this kind of U-shaped graph. Little bobble there, but you get the idea. Okay, so that was our basic graph for x squared. So now what we want to do is we want to look at some variations on this graph that we already know and hope that we can make some relationships between these functions that look very similar and hope that the graphs look very similar. So let's look here at this one, y equals x squared plus 1. So we see the x squared there, but what does this plus 1 do? Well, I've already charted the numbers here so we can see them. If you plug negative 2 in, you'd have negative 2 squared plus 1 is 5. Negative 1 squared plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. And 2 squared plus 1 is 5. So we get these points here. Now, we don't want to plot points for everything we come across, so let's see if we can see a relationship between our x squared numbers and our x squared plus 1 numbers. Now I kept the x numbers the same, and I did that intentionally, so let's look at the y values here and see if we can see a relationship. What is the change in y values from our first graph to our second? So if you look, every time we were doing x squared, then we were doing x squared plus 1. We have x squared, then x squared plus 1, plus 1, plus 1, plus 1. So if you look at the y values, every y value is the y value that we had before, plus 1. And that would be true no matter how many charts like this we looked at or how many x values we looked at. So all of our y values go up by 1. Well, what does that do to the graph? Think about it. If you take all of the points of a graph and you change the y value and you add 1 to every single y value, what's that going to do? We move up 1, up 1, up 1, like this. Now that one bobbled a little bit. That one bobbled a little bit, but you get the idea. So if we move all of the y values, if we add 1 to all the y values, that's going to move the graph up by 1. So add 1 to all the y values, that moves the graph up by 1, and now we get the blue graph. Okay, so that's x squared plus 1. And the red graph was our x squared. Okay, well that seems to make enough sense. So now what would happen with our x squared minus 2? So each time we're taking our x, we're squaring it, and we're subtracting 2. So we get 4 minus 2 is 2. 1 minus 2 is negative 1. 0 minus 2 is negative 2. Oh, this is a mistake. Right here, this should be a negative 1. And then when we plug in 2, 4 minus 2 is 2. Okay, so this is our table of values for x squared minus 2. So going back to our original picture right here, original chart right here, and comparing it to our new chart, again the x values stayed the same. What happened to all of our y values? Well, each time we're doing x squared minus 2, minus 2, minus 2, minus 2, minus 2, look at all of our y values. All of our y values are minus 2 from our original chart. So what is that going to do to the graph? If you take all of your points, every single point on the graph, and you take away 2 from the y value, that should move all of your points down by 2. So let's check that out. We've got negative 2, 2. We've got negative 1, negative 1. We've got 0, negative 2, 1, negative 1, and 2, 2. And sure enough, our graph is the same. We've just moved it down by 2. Okay, so hopefully that's easy enough to see. We're taking what we had originally and we're adding 1 or we're subtracting 2, and that moves all the y values up or down by 2. So the general rule for this, let me give myself some space here. The general rule for this is that if you take a function that you know and you add c to it, c is a constant, or you subtract c from it, so you take a function that you know and you add or subtract a number to it, that's going to shift the graph up or down. So take your function and add a number to it, and that's going to shift the graph up by c. And if you subtract c from it, that's going to shift the graph down by c. All right, we used x squared as an example because it's easy to work with. The numbers are fairly simple, and it's good to see the picture. But actually, this works for any graph. So if we think back to some of the graphs that we looked at before, let's say we want to do f of x is equal to the square root of x plus 3. All right, we want to sketch this graph without having to graph a bunch of points. Well, you see the square root of x. You think, okay, what does the square root of x look like? And you remember that graph from the last section. And this plus 3 right here, this plus 3 is going to move the graph up 3. So you take the square root graph that you know, and you shift it up 3. So let's sketch that. So we go 1, 2, 3. And remember that we've got that half of a parabola on its side looking thing. And we sketch that in. Okay, so this method works for all of the graphs that we looked at before. All right, so we've looked at one variation on our familiar function y equals x squared, and now we're going to look at a different variation. So what happens if we add or subtract a number now inside the function? So see, this minus 1 is inside the square, and this plus 1 is inside of the square. On the other ones, we added it on the outside of the function. So again, we've got our x squared. I've already graphed that. And we've got our familiar points. So negative 2 to 2, and we've got 4, 1, 0, 1, 4 for our y values. So all of that should be familiar. Now, what happens when we have y equals x minus 1 squared? Well, when we put in the negative 2, remember your order of operations. You're going to have negative 2 minus 1, that's negative 3. Then square it, you get positive 9. So plug in negative 1. You get negative 2 squared is 4. Plug in 0, you get 1, 1, 0, 2, 1. All right, so we look here, we've kept the x values the same, and we look at the y values. This time the pattern's not as easy to see. How do these y values relate? Well, if we looked at a bigger table, or maybe if I add one more number to this, let's say we plug in the number 3, we're going to get 2 squared is 4. Okay, if we looked at a bigger table, you would almost definitely see the pattern. But here, you may see it now. So if we look at this, our x values are negative 2 to 2, and our y values are 4, 1, 0, 1, 4. Well, we see those same y values here, but they're happening in a different place on the chart. So if we looked at a big table of this, you would see that all of the y values are the same, but they're shifted. They're going with different x values. And that's because we're going to do whatever number's in here, we're going to do that before we square it. So we end up with the same y values. They're just associated to different x values. So let's look at what's happening to the x values. The x values, if we look as we go, the x values are going up by 1. The x values have to go up by 1 because then when we do this minus 1 and square it, we get back to where we were before. So it seems kind of backwards, but when we have x minus 1, our x values are actually going up by 1. So think about what that does to the graph. If you take all of the points on a graph and you add 1 to the x value, picture that in your head, that should move us to the right by 1. So this should move all of our points to the right by 1. So let's go ahead and graph them and see what happens. Let me go back to my green. Okay, so we've got negative 1, 4, 1, 2, 3. Negative 1, 4, 0, 1, 1, 0, 2, 1, and 3, 4. And sure enough, we can see that the green graph is the same as our original graph, shifted to the right by 1. Okay, so let's look at this one, x plus 1 squared. All right, so again, we compare this to our original here. And again, we don't really see the relationship, but if I add in a number at the top of the picture here, if I add in -3, when we put in -3, we're going to get -2 squared. We get 4. And now we can see that same y pattern, 4, 1, 0, 1, 4. And we see that the x values have gone down by 1. So if you take all your points and you move the x values, take 1 away from all the x values, what does that do to the graph? If you take 1 away from all the x values, it should shift you to the left by 1. So let's look at the picture and see what happens. We've got -3, 4, -2, 1, -1, 0, here, and here. Okay, so we can see that the blue graph is just like the red graph, but shift to the left by 1. So the rule here is that if you add or subtract inside the function, this is also a graph shift, but it's opposite of what you'd expect. If you subtract by a number, that's going to shift you to the right that amount. And if you add a number inside the function, that's going to shift left by that amount. Okay, so and when you add or subtract inside the function, it's going to be a shift left or right, and it's opposite what you'd expect. Now again, we did this with x squared, but we could do this with lots of different functions. You would see that they all work the same. This will work for any function.